We're looking at the trend now, and there are two types of shading that we can do. We can either do a shade in, or we can shade out the area, and I'll show you both of these types. Now there are highlighters available in my top drawer over on my Students Are Welcome to Borrow. I think it's the blue drawer that's got highlighters in, but please return them when you're finished. So once we've shaded in, we then have to look at that, what we've shaded in, and say, does it look like it's a straight line, or does it look like it's some kind of curve? And there's a whole variety of curves that you might remember with your quadratic and your cubic and your log and all sorts of other types. Okay, we don't need to say what type, but just remember curves can be all sorts. So if we're looking at a linear trend, so say I've got a set of data like this, then I could put a straight line through that. I could put my ruler over top and it would fit quite nicely. So that means I've got a constant gradient. And if you think about the stairs that we walk up and down, each step that we walk up and down is the same height and the same width. And that's what a constant gradient is. It's something that as the x variable increases, the y variable increases, and that each step size you take, the x and y are changing by the same amount. If, however, I've got some kind of curve, and this one we can see it starts to curve, it's heading upwards, and then it starts to curve towards the end, going towards down. So in this case, that step size would not be the same. So this is like going for a walk in the park, in the bush, when you've got the different hills to go up, and sometimes you've got really big steps that you've got to step up tall, and sometimes really long, shallow steps. So that is a non-linear trend. So that's what we're looking for. Or we could be saying there's no trend at all. If the data is just randomly scattered and there's no areas that I can shade in or shade out, then that just means there isn't any trend. There's no relationship. So if I take my fuel efficiency, and you can see here I've shaded this out, okay? So that's, I'm shading out the areas and colouring them in where there aren't any data. The other way is to shade in, where I shade in the block of where the data is. So you could do either of these things. The key thing when we look at both of those is it gives us a reasonable indication that this data set might well be a linear data set. Okay, that if I put a straight block on over it, it might well be a straight line. So our trend description needs to state this. So we've got to state that the trend is approximately linear, and I've got to state both my variables in there, and then I've got to describe it in more detail. So on our x-axis, if I just go back to the graph, on the x-axis is the weight. As that weight is increasing, so 600, 800, 1000, 1200, as that weight is increasing, what is the fuel efficiency doing? Well, the fuel efficiency is going down. Okay, so it starts at values up about 45 and goes down towards values around about 10, and it is going down at a steady rate. Okay, so that's the key idea, is that the fuel, as the weight is increasing, the fuel efficiency is slowly decreasing, but it's a constant rate. So that means our gradient or our slope, depending on which terminology you prefer to use, so it's that the slope between the weight and the fuel efficiency is, and that should say decreasing, not increasing. Okay, but the key there is that it's at a slow and steady rate. That's why it's linear. If it was non-linear, it would be going at a non-constant rate, and so there would be a non-steady rate that it changed at.